Hello everyone, my name is Rutuja Vijayarao Pimparkar. My project title is Predicting Cigarettes versus Alcohol Addiction Using Demographic Features. This project explores whether demographic features such as age, gender, income, education, and marital status can predict whether an individual is more likely addicted to cigarettes or alcohol. To do this, I applied two classification models, logistic regression and random forest. The goal was to determine whether demographics alone are strong enough predictors to distinguish addiction type. This question matters because substance use behavior often varies by demographic group. If predictive strength is low, it indicates that deeper behavioral or psychological indicators are needed. The dataset includes 3,000 individuals with demographic and behavioral attributes. To create the classification label, individuals who smoked more than they drank were labeled as cigarette addicted, and those who drank as much or more than they smoked were labeled as alcohol addicted. Here we can see that target variable is heavily imbalanced. About 88% of individuals fall into the cigarette addicted group and only about 12% into the alcohol addicted group. This imbalance plays a major role in the model's performance. Moving on to the methods and pre-processing steps. First, I clean the dataset by handling missing values and encoding categorical variables. For example, gender and education level needed to be converted into numerical form so the models could process them. I also scale numerical values like age and income so they are easier for the model to understand. After pre-processing, I split the dataset into training and testing sets. For modeling, I use two approaches. First, logistic regression, and second is random forest. Here, we can see the accuracy results of both models. Logistic regression provided a straightforward baseline, while random forest performed better due to its ability to capture more complex interactions between demographic variables. Accuracy gives us an initial understanding of each model's performance, but it is not enough on its own, especially for classification problems. So I have also looked at the confusion matrix and feature importance. This confusion matrix helps us understand where the random forest model predicted correctly or where it made mistakes. The model is highly accurate on the majority class, correctly predicting 525 cigarette addicted individuals but only 2 alcohol addicted individuals. The imbalance overwhelmed the classifier, causing it to predict the majority class almost every time. This graph shows which feature the random forest model found most important when making predictions. For example, if age ranks high, that means age contributes strongly to distinguishing between cigarette and alcohol addiction. Gender, marital status, and education level have very little predictive impact. This reinforces that demographics alone do not create a strong separation between the two addiction types. Logistic regression coefficients show the same trend. Gender categories slightly increase the likelihood of alcohol addiction, while marital status categories increase the likelihood of cigarette addiction. However, the magnitudes are small, and age and income have coefficients near zero, suggesting weak linear separability. This chart shows the age distribution within the dataset. It's useful to examine whether one addiction type is more common among younger or older individuals, as age turned out to be one of the strongest predictor. As we found, the primary takeaway is that demographic data alone cannot meaningfully distinguish between cigarette and alcohol addiction. Even though accuracy appears high, the models essentially fail at the true task of predicting the minority group. This project also has several limitations. The main limitation is the imbalance. Additionally, um, addiction behavior is strongly influenced by psychological, behavioral, and environmental factors, none of which are included here. This restricts predictive power and limits what machine learning can learn from the dataset. To conclude, this project demonstrates that machine learning can help identify patterns in addiction behavior using demographic data. While not perfect, the models provide meaningful insights and show potential for supporting public health decision making. To improve predictions, future analysis should include richer behavioral and psychological data. Thank you.